hello. Hi guys, good morning. Welcome back to a new video. This is question number 2. Question number 3 and 4 are already live on the channel of today's weekly contest 390. Apply operations to make sum of array greater than or equal to k. Although it's an easy problem, but still we will see the math variation of it, which actually makes this problem a bit tricky and a bit hard to understand. Okay, like usually it's easy, but sometimes math can be very complex. Now it just simply says again that can be simply solved by brute force, which is simple logic. We'll see first and then we'll see the math approach. Simply say that we are going to positive integer k, and initially you have an array of nums which have only single value, which is 1. Now you can perform any of the following operations any number of times. Operation 1 is choose any element in the array. For sure you have only one element, which is 1, and increase its value by 1. So 1 will become a 2. Then you can choose this, make it a 3. Choose this, make it a 4. Choose this, make it a 5. You are just choosing that value itself and increasing its value. Other operation is duplicate any element in the array and add it to the end of the array, which means if right now, let's say you would have been increasing, you have been using option 1, but then you thought of, okay, I'll now duplicate it, which means 3 is now again 3. Maybe you try to duplicate now again 3. Now maybe you thought of, okay, let's increase it. You increase it to 4. So this has become 4. Now you thought of, okay, now again duplicate, okay, 4. So this is what and how you will go about doing stuff. Now it just simply says to return with the minimum number of operations required to make the sum of elements of the final array greater than or equal to k. Sum of elements Aryan, because Aryan you only had one element. No bro, you can increase an element, you can duplicate the element. So it is kind of, okay, you have one element, you have the value 1, but you can increase it. You can increase it, and then you will start duplicating it. Okay, let's say duplicate it again, make a 3, again make a 3, again make a 3. So now first thing is, Aryan, how would I know that at what point I should start like increasing, and at what point I should stop increasing and start duplicating, and then again maybe I would start increasing again, which means, okay, 1 increased to 2, increased to 3, then you stopped increasing and you start duplicating. Okay, again a 3, again a 3, then you thought of, okay, let's start duplicating, so let's start increasing 4, then maybe 5, then start duplicating 5, and then 5. So you will see, okay, I have 3 3, I have 5 5 5. So Aryan, how would I know that what combination I should choose for? First, let's imagine greedily how many steps you took here. You increased, then you duplicated. Okay, that's one step here, and then you again duplicated. That's another step here. Then you again increased it. Okay, one step here. Now I will ask you, bro, if you knew one thing, that you have to get a 5 5 5, I'll ask you, what is the point of duplicating right now? What is the point of duplicating? Rather, if you have stopped and duplicated not here, again, you knew that one operation took at this step to duplicate. I'll say, bro, ignore this operation. Don't duplicate it right now. When you have reached the final max value which you wanted, duplicate it here. You will have a larger value. So, with that fact, greedily we realized that firstly, I will always increase. Then when I am done increasing, then only I will start duplicating. So we know that something of pattern of this sort will look like. But now it's in question, Aryan, at which point I should stop increasing and start duplicating? That's a question for me. Bro, it's simple. Again, the number of increase which you will do, I will name that as A. Number of duplicates which you will do, I'll name that as B. Now, increasing is one operation, duplicating is other operation. So your final number of operations required will be A plus B. That's just the term I'm using right now, so as to tell you what and how things can go about. Now, coming on back, that Aryan, again, I'm just confused. At what point I should stop decreasing and start duplicating? That's it. That's a question for me. Okay, bro, that is great. You know that you have k. You have to build k. I will say, what if, bro, what if you did not, you never increased, you started duplicating from the very beginning itself? Then you will have 1. You will end up duplicating k times. I should be more precise, k minus 1 times you will duplicate. Your b will be k minus 1 to duplicate something k minus 1 times to get the sum as k. So in worst case, I might end up duplicating k times. Now, again, Aryan, you never answered a question. I asked you when I should stop increasing and start duplicating. I will say, bro, try for all possibilities, which means, okay, increase nothing, duplicate everything. Increase just one time, then duplicate rest of the time. Increase two times, duplicate rest of the times. Increase three times, duplicate rest of the times, and see which will give you the minimum operations. And Aryan, can I do this? Can I try increasing up till a is equals to k minus 1? Can I do this? Which means I will be needing these k. My k loop, my loop as k will go to these my number of steps. Can I do this? I'll go into constraints. My constraint is 1 Oh, I can for sure easily apply a loop, a for loop of k, so that I can try for all the possibilities that, okay, I will increase just, I will never increase, I'll increase once, I'll increase twice, I'll increase thrice, I'll increase four times, and then again remaining portion I will start duplicating. So let's take a simple fact. Let's say I increased a number twice. So one, after I increase it twice, it will become a number 3. So my current value, again, this is my a. How many times I increased the number? Here I'm saying I increased the number twice. Okay, let's take it a pink color. I increased the number twice. So I said I increased the number twice. So my current value of the number will become a 3. Now I'm asking you, bro, your aim was to make a number 11. Your aim was to make a number 11. How many times you should start duplicating it? Which means 3, then 3, then 3, then 3. How many times you should duplicate that, so that your this specific addition of these numbers after duplicating, it should become more than equal to your 11. I know that all these numbers will be 3, 3, 3. I just want to know the frequency of those numbers. So let's imagine that, okay, I again remember the fact, this is what you are actually duplicating. Your b count is this much, but I'm saying in total this is the value which you are actually concerned of, right? This is, you will actually say, okay, 3 multiplied by x should be greater than equal to 11. So x should be greater than equal to 11 by 3. I will simply say that I will be multiplying these many number of times. My number 3, I will multiplying it, or I can say I will duplicate this number 3 these many number of times. How many number of times? I can simply go and start. You have your number. I know that your current number which you have made right now, the current value has reached to 4, in which you increase twice. How many times you start duplicating? Let's say I duplicate x times. I don't know what's the number. I'm just finding out what should be the optimal or the minimum value of x, because I want my a plus b sum to be minimum. A is fixed, b is I'm trying to minimize. I'll say my value should be more than equal to 11. It should be more than equal to 11. So basically 11 by 3. Now 11 by 3 value says, okay, 11 by 3 is 3. For sure, you will just by default take a simple floor value 3. So Aryan, are you saying that I will have my 3 times? 3 plus 3, 3, which means I will have my 3 times. That will give me 11. No, bro, this 3 times gave me a number 9. Oh, I cannot take a floor value. Floor value is not allowed for me. That's haram for me. So what I will do is I will actually take in the seal value. Okay, bro, 3. Which means this will give me 3 should be multiplied, or 3 should be duplicated. I should say duplicated, which means 3 in total should be 4 times. 3 in total should be 4 times. So I will say take a seal value for it. Take a 11 by 3, 11 by current value. Take a seal value for it. And the seal value of this x came out to be a 4. So I should have my 3 4 times, which means how many times you duplicated that? In total you have 4 times. This is 4 times. 1 was by default already there, so number of duplications, which is b, is nothing but this value x minus 1. So I can simply say that if I just say, okay, x was equal to 11 by current value seal, so if I just populate that value here, I can simply say that my b is k, because this 11 was k. If you remember, your 11 was k. This is your k. So I can simply say my b is nothing but k upon your actual current value. Its seal value minus 1. Again, for the folks who don't know, this is the seal. C-E-I-L, seal. This is the seal value. Now, if you remember, this current value was what? Current value was nothing but, if I go back, current value is nothing but your a value, and for sure by default you will have 1. So whatsoever a you assumed, you will say, okay, by default I had a 1, I will increase my number by a times. So your current value at that point will become 1 plus a. So this will be nothing but your 1 plus a. And thus by fixing your a, you can see what is your minimum b. And you will try in for all the A0, A1, A2, A3 up to so on and so forth, and you will find out what is the corresponding B which you need, and whosoever will give you the minimum A plus B combination, that you will take. And for sure you can try for all the values from A equal to 0 to A equal to K minus 1. Let's see the code. It's pretty simple. Again, remember this entire logic, because what we will see the next math approach, which will be because you can see it's a O of K approach. O of K approach, but next approach 2 will see a math approach in this exactly same funda I will use, and I will not repeat that funda again. But yeah, let's see the code. It's pretty simple. It's a simple brute force code. Again, I took this condition. You want, you can do it. If you don't want, it's up to you. But then I went on again. This is the minimum operations. This is nothing but I have to minimize a plus b sum. I will try in okay, this is the code which I did not change. Let me show you the code which I changed. So this is the code which I will take. Now in this you can see what happens is, again, for the more simplicity of the next approach, I changed this code. This is the code, the one which I showed you here. This is the code which I wrote firstly, but then when I did the math approach, in that how I showed you the code, that same way I tried to change this code also, so that you are in sync of the approach and you don't have to stress your mind much. So what is thing, I'm trying for all the possibilities as I showed you, from a equal to 0 to a is less than k and a plus plus. Then corresponding b I am trying to find by ceil value of k upon a plus 1. The same way I showed you. It is k upon, where it is gone? Where is this gone? Yeah. Sorry. Yeah, it is ceil of a upon, ceil of k upon a plus 1. As you can see, ceil of k upon a plus 1, and then minus 1, because I know that 1 is already there. Duplicates, extras 1 are actually nothing but my b value, so I'll have to do a minus 1. And ultimately minimum operations is nothing but minimum operations of a plus b. A is from the loop which I am trying ultimately, and b is I found out with the help of a itself, and ultimately I will return my minimum of operations. So you saw that this will be O of k operations. Time will be O of k. Now a bit example with the actual stuff as I showed you. Let's imagine again, in the example I showed you when your a was actually 2, let's imagine your a is 3, which means the increase part required was 3, which means you have to increase thrice. So for sure your current value, you can say, will be your a plus 1, which is 4. So if your a plus 1, which is 4, so you can simply say that my current value is 4 itself. And the same way you will do again. Now let's come on to, again, if you want to complete this, I can just complete it very quickly. So if your a value would, again, this is a different value of a which I'm showing you, or I'm just telling you to try off. Then your current value is 4. Then you will have your k by 4 ceil value, which will give you a 3, because 4th here 12, so it will give you a 3 value, which means ultimately 3 times you have to multiply something. So I mean 2 extra times. So duplicate will be twice, so b value will be 2. So you can simply say the value will be a plus b2. But remember this one fact, that you have to also make sure when you are doing ceil, so some things can go a bit here and there. So I showed you also that 11 by 4 ceil value will give me a 3. 12 by 4, which is completely divisible, its ceil value will also give me a 3. So as the ceil value is the same for both of them, so I don't need to worry about anything whatsoever. So ceil value, make sure, okay, both things are same. I will just say 3 times the total number of multiplications I need to have. So it will be 2 extra times I will have to apply from my side, because 1 will already be there, 2 is the time extra I have to apply, because it is b. B is the number of duplicates which you have on top of existing one. Now coming on to a math approach, for sure we will just, what we were doing, we were trying for all the possible values of a, and then we were trying to find, bro, what is the a plus b minimum value. We'll do the exact same thing, but in the simple, we'll use a math concept in this. How we will use it? We'll simply say, initially I had a value of 1, now I incremented that a times. For sure, I will, again, a times is any number, any arbitrary number. Earlier, I was trying for all the possible values of a, but now I'm saying it's an arbitrary number. So my existing current value will reach to a value of a plus 1. Now I will say, okay, bro, a plus 1, if I duplicate that number, a plus 1, if I duplicate that number b times, I don't know what's the operation, but yeah, if I do that number b times, then for sure I will be multiplying, again existing number will be there, I will be multiplying that number b times. I mean I will be having that duplicate b times, so I will have a plus 1 b times, so this number will become a plus 1 into b plus 1. Now by the question saying my a plus 1 multiplied by b plus 1 should be more than equal to k. If I expand that, I can simply reach to a point where a into b plus a plus b plus 1 should be more than equal to k. Now remember the fact, मकसद नहीं भूलना, your main aim was that your a plus b should be minimum. You have to minimize this value, which means this portion should be minimum, this portion should be as minimum as possible. This one is constant, so you will have to try and maximize the value of a multiplied by b. You have to maximize the value of a multiplied by b so that this portion is more than equal to your k. So maximize this. Again, if you want to maximize a multiplied by b, if you want to maximize two numbers multiplication, that's only and only again when their values are fixed, which means I can say okay, the sum of the values are fixed, and if I want to multiply two numbers, the maximum multiplication is possible when these numbers are as close to each other as possible. For example, if you know the sum of a plus b is, let's say 11, right? 4 into 7, you know it is 28. I know that a into b will be as maximum as possible when the both numbers a and b are as close to each other as possible. So I can say 5 into 6 will give me the maximum multiplication possible, which is 30. And this is a simple math funda which is extra, which is used in this problem, that to know, okay, a into b, this needs to be maximum, so both the numbers a and b should be as close to each other as possible. Now considering the best possible case is both a and b are equal, right? So let's imagine, again, that's not always true. A and b can never be always equal, and we can for sure see in this question itself, my a was a 3, and for this example itself, when your answer was a 5, you can simply see that your, again, a was a 2 and your b was a 3, which came in this problem, which is 3. So you know, okay, for the optimal approach also, a and b can never be, like, not necessarily be equal, they can only be equal for sure. In this case also, you have this a and b as 11. Okay, if a plus b would have been as 12, it is still possible to have your a and b equal, which means 6 and 6, which would have given you the maximum multiplication, which is 36. But in this case, a and b can never be equal. So for sure, in these cases, what you will do, let's consider the best case possible. Let's imagine if a and b would have been equal, then I would have said, okay, a plus 1 whole square is more than equal to k, a plus b is more than equal to root k, a is more than equal to root k minus 1. Let's say this is the best possible case. Now if I take, again, in these cases, always when the math is involved, please go back to an example to verify some things, that something is correct. Again, this is half truth. This is only when a is equal to b, which means I am considering both a and b are equal, which is never, or basically which can be or cannot be true depending upon the problem itself. Where let's imagine if a k is 11, for sure you will hand and say, okay, my a value should be more than equal to your root k minus 1. Now your root k will be a floor value, that's the reason you have greater than equal to. So I will take a ceil value to always make my a more than this value itself, right? So I will take my a, the ceil value, I'll take this root k ceil value. So I'll just say, okay, you have a root 11. Root 11 by default will be 3 point something. I will say, bro, take the ceil value of it. I want to take the ceil value of it. So it will give me a 4. Now I have taken, so it will say me, bro, that you have this value of a value will be 3. I just simply said, bro, this is your k. Root of 11 will be your 3 point something. Take the ceil value, which is you will become a 4, but I will need the 3 extra increment operations. Okay, bro, if you need 3 extra increment operations, that's great. That's completely fine. I will increase thrice. But now your task is to find what is the corresponding b. But you will simply go and find the corresponding b as minimum as possible. And again, we will use the exact same approach. We know our a is this. This is our optimal a which we wanted. And in the above approach, what we were trying for multiple a's. But now in this one step, we have reached to an optimal a. Corresponding b we can simply go and find us. So what we will do is, okay, we know that if this is the a, the current value will be nothing but a plus 1, which is 4. So what is the value of b required? I know that 11 by 4, I know that this value 4 should be multiplied how many times? How many times? For sure, 3 times. So I did what? Again, 4 into 3 will be a 12. So I am saying in total, this 4 should be multiplied by 3 times, should be multiplied 3 times, so as to get a number which is more than equal to your number k. So I'm taking a 11, which is k by this current value, seal I am taking, so as to get the total number of times this number should be multiplied. I am saying this number should be multiplied 3 times. So B, duplicates, extra ones required will be 2 times, which is total number of times minus 1. So with this fact again, I just showed you that you can also verify that seal will work perfectly for both the numbers. Either it is 11 by 4, still the seal will be 3, and that's what you also require. And same for 12 by 4, seal will be 3, and that's same what you required, which is the total number of multiplications. So you saw that seal value minus 1, seal value B will be the seal value of this, minus 1 will be your actual value of B, which you actually required. Now you remembered what is this A value? This A value is nothing but your seal value of square root minus 1, seal value of square root minus 1, your A value, which earlier you were trying for all the A values. Now you have fixed this value by saying, okay, it's the most optimal one. And then corresponding B value you have simply found out by using the exact same approach as you were doing earlier also, by saying B is equals to seal of k by a minus k upon a plus 1 minus 1, and thus your answer will be a plus b. Let's see the code. It's pretty simple. Firstly, you get the seal. A will be nothing but your seal value of square root of k minus 1, exactly same, square root of k minus 1, and your b value will be nothing but your seal of k upon a plus 1 minus 1, seal of k upon a plus 1 minus 1, seal of k upon a plus 1 minus 1, and your answer is nothing but a plus b, and that's the minimum possible, and the time here is O of 1. Now this question was solvable because your time of O of k was okay, but what if the interviewer asks you a O of 1 approach? Then you should be knowing that. And if the constraints would have been k as 1 in 9, still this would have been your go-to approach. Again, both the cases, brute force also and this also, involved maths, but this is pure maths. Cool. Thanks for watching. Bye. Take care. Bye bye. It's actually a good problem, I'll say. The hardest problem, I should say, will be question number 2, this contest. Bye bye.